Okay, we have a video here on the natural logarithm and the Euler number e. Just like pi, the symbol for pi is something similar to this. For imaginary numbers, we use the letter I. Um, the Euler number is also represented by a letter, the letter E. And a lot of times you'll see it italicized in problems or in books. The natural base E is an irrational number. It was discovered by Leonhard Euler, and I think I pronounced his first name right. If not, it's close, and I know his last name is correct. Euler was born in 1707 and passed away in 1783, and so the natural base is considered the natural base E was considered to be found in modern times. It's fairly new to mathematics, considering everything that has been created a long time ago in mathematics up until present day. So this one is fairly new. If we were to take this out to 50 decimal places, this is what it would look like. Remember, we said it was irrational, so it's not going to terminate and it's not going to repeat. You can see that it's close to 2.71828. So something like that. Typically, we won't use that. We'll use it is in the calculator. There's a special button, just like the pi button. There's a natural base E button there. Working with it, I mean, you work with the same way you work with, variables. Same way you would work with pi. X cubed times x to the fifth is going to be x to the eighth. Pi cubed times pi to the fifth is going to be pi to the eighth. And so this should be e to the eighth. The rules, the properties still follow. The exponent properties still follow, even with the natural base e. And if we see here, 12 divided by 6, of course, is going to be 2. And we have 8 e's on top, and we have 10 of them on bottom. So that means we have 2 more e's on bottom. And so we're going to leave it like that. We could type it into the calculator and get a decimal if we wanted. That's not necessary at the present moment, though. And if we look here, it's still the same. First off, I'm going to deal with a negative, so I'm going to go ahead and make it the reciprocal at the present moment. Negative exponent means you move it to the other side of the fraction bar. And so when it was green, it was on top, and we changed it to the bottom. And now we just take the 2, and it goes with both things. So that means we're going to have 1 over 5 squared, which is 25. And then whenever we have a power raised to a power, instead of adding like we did here, we are going to multiply. So 3x times 2 is going to be 6x. So this is the simplified version of that. And so it's just simplifying right there. All right, so if we look at something like this, we've already worked with logarithms, and if not, you may want to review logarithms. So if we're seeing something like this, we know that if we take the e and make it a base, and then the x will be there, and then we know that's equal to that exponent of y. And so this is how we write it. And so from here, we could possibly figure it out. How, you might ask, how can we do that? Well, you might start thinking that we're just going to type log into the calculator, but remember, when we type log into the calculator, it is dealing with log base of 10. The log base of 10. And so this has a log base of e. So how do we deal with that? Well, when we deal with log, when it's written out as log, that's a common log. common logarithm. And so you can work with those. You've already worked with those a little bit. But the thing is, if we have log with a base of e, we can change this to ln, which is natural log. I believe it's Latin for something like logarithmus naturali, I think. Uh, I haven't looked at my Latin for a long time. Actually, I never took Latin, so. But I'm pretty sure that's what it stands for, at least something close. So that's why it's ln and not nl. But anyway, so here we have the natural log, and that's what log of e can change to. The natural log of x is equal to y. And you see in this example, so if we have e as the base, we put 8 there, and then the exponent is what it's all equal to. That's how we can solve for y. Because remember, e is a number, 8 is also a number, and y is the variable, and that's what we're trying to solve for. So once we have log with the base of e, we change it to natural log, and so we have the natural log of 8. So let's clear this out, and you see ln down here in the bottom right, and you see it right there. So we're going to press natural log of 8, and this is what y is approximately equal to. If you wanted a decimal for that, you did not have to have a decimal. I think you can just leave it as the natural log of 8. That's the exact answer. If you needed a decimal, you can change it there. All right, so let's look at this next example here. If we have e raised to the y power is equal to 10, we're trying to solve for y. Well, we know if we take the natural log, that's the natural log of 10 is going to be equal to y. And you notice I just skipped this part of saying log base of e to 10 is equal to y. I just skipped this part. And so you can type that into your calculator, get a decimal, and let's see you try the one on the right. E raised to the y power is equal to 25. Let's see what you come up with a solution there. The natural log of 25 is going to be equal to y. And so if you want solutions, natural log of 10 and natural log of 25. There we go. And here's the last slide that we have. Solve this out for y. I'm pretty sure you're going to say the natural log of 1 is equal to y, and the natural log of negative 10 is equal to y. Well, let's go look at those. Actually, let's look at the graph. I have graphed natural log of x. That's what I have graphed. And if we look right here, actually I think I'm a little bit to the right. If we look right here is actually where x would equal 1. So what do you think that looks like? What's the y value there? How far up or down does that go? Natural log of 1. And that look like it goes up and down 0? So that point right there would be 1 to the right, up or down 0. So the natural log of 1 is going to be 0. Now what about the other one? We had the natural log of negative 10. And so if we try to imagine natural log of negative 10, well, the graph is going here, and so use your knowledge about what you know about asymptotes. Does it look like that'll ever go past the y-axis there? The equation is x equals 0 for that. Does it ever look like it'll go past there? I believe it's just getting super, super close. And so, of course, if we're trying to figure out where that's where x equals 10, what's the y value for that? And so that's the reason why when you type it into here, it's going to say that there's an error because it's a non-real answer. We'll press number 2 to go to it, and it'll take us to that, and it'll say -10. And it's the negative part that makes the this a non-real answer. And so this is going to be natural log of -10 will be a non-real answer. And so if we look, this is just a quick introduction there for natural logs, and just working with simplifying, working with instead of using log with a base, the common logarithm, now we're starting to use the natural logarithm, ln, with a base of, well, ln, remember, is just log with a base of e. So that's basically all I have for you. If you got any questions, let me know.